All right, I guess we'll get started. Use my power supply for a bit of heat. It's really cold in here today. Oh, jeez. All right, we'll recap last week's lesson like usual, and then we'll get into today's lesson. Mondays took about 2 hours to complete the whole thing, so we might be able to end a bit early, which would be nice. There will be a quiz, obviously, and then the lab will be just whatever we complete like usual. All right, so last week we talked about basic syntax rules, arrays, and loops. We just got into a little bit about the basic syntax rules of JavaScript. We talked a little bit about the semicolon. Semicolon terminates a statement, as you guys already know. That happens in Java. You guys have used Java before. I'm sure you guys did PHP programming. You're using ASP.NET. All those languages all terminate with semicolons. JavaScript, it is technically optional, and when you start working with like Node, it becomes a little bit easier to use it optionally, but when you're using client-side JavaScript, I do recommend using the semicolon just for the purpose of avoiding bizarre errors that you might have, where the statement accidentally runs into the next line and kind of gives this idea of where it thinks the two lines are connected when they're not. So I just recommend using semicolons. It'll save you a world of hurt. We talked about assignment versus comparison. I'm going to talk about assignment versus comparison again tonight because in Lab 2, again, same issue. It's kind of important that you understand this concept. Like, this is like a basic programming concept. When you do assignment versus comparison, right, we're talking about if conditions in this particular scenario. If I write, for example, name equals Sean, right? And I'm just going to write a return. Okay? Now just to throw a bit of a monkey wrench in it, just before name, okay. Will this execute? How many people say yes, it will execute? How many people say no, it won't execute? Okay. You're on the fence?
I really am.
You're on the fence? Let's follow the logic here. Name is equal to Bob, right? If name equals Sean, return name.
What did that return, Sean?
Exactly. It'll return Sean. Why will it return Sean?
But isn't the same code block assigning Sean?
Exactly. Because we are assigning. That's what's happening here. This is basically saying name is equal to Sean. You are now equal to Sean. You can think of it like it's an order, more so. This is now equal to this. That's what it basically means. If I want to change this to make this false, what would I do? Yeah, double equals sign would work for sure. Yeah, which one is the best method? The triple, right? Because that evaluates what? Value and data type, right? This says, this is a question. That's what's occurring here. This is a question. This is saying, is name equal to Sean? Is it? No, it's equal to Bob, right? So because of that, we're going to return the name back. Okay? So, just a heads up. I've been kind of pretty nice about it, and I've only written like a small comment to let you know if it is an issue with your particular lab. I'm just going to deduct like the whole points for that section in the lab from now on if I see it again. Only reason being is because that's like programming 101. Like that's first semester, first class, maybe not first class, maybe you guys did conditionals in third class. But either way, it's way back there, right? It's every language, it's not just JavaScript. Every single language has conditionals. That's something you really got to get in the habit of doing it. So I think a good penalty will definitely get you in the habit of doing it. So remember, assignment versus comparison, they are very different. Commenting. We talked a little bit about commenting. This is pretty basic. You guys told me that this is exactly the same commenting that you get in Java, so that should make things nice and easy. It's also the same commenting you get in PHP as well. It's different in some languages like Ruby. I think it might be different. It's different in CoffeeScript too, a few others. But for the most part, it looks like this. Single line commenting is done with the double /, and the multi-line comment is done by wrapping it inside the / asterisk and the asterisk /. Cool. We talked about arrays. You guys have worked with arrays. Now, granted, the arrays you guys probably worked with were data typed. In JavaScript, they're not data typed, which is kind of convenient at times. However, it is usually a good idea to try to maintain consistent data when you're working with an array. We talked about nested arrays. It's not often that you're going to use these, but it is advisable that you know, especially if you're building out, huge reports and you're working with CSV data and stuff like that. It's usually a good idea to understand what a nested array looks like. We talked about the mighty console. Command-Alt-J if you're on Mac. Bleh. There we go. Command-Alt-J if you're on Mac. Control-Alt-J if you're in Windows. Control-Alt-J if you're on Linux. Depending on the browser you're in. Some browsers don't support that shortcut code. If you're in Safari, you'll have to go through the Developer Tools menu. But if you're in Firefox or Chrome, it's just quick. If you're in Edge, I believe it's Control-Alt-I to get there. But the console is really, really important to understand because the console is how you can test JavaScript. You can actually type JavaScript directly into the console, which makes it super powerful for you because you can test code chunks without needing to commit them to your IDE yet, which is pretty cool. So I definitely recommend getting used to the console. The console is also going to tell you if there's issues with your code. So if you have a syntax error, it will tell you what line the syntax error is. It will tell you some sort of code error that basically will hint to what's wrong. They're not always crystal clear. They don't always necessarily tell you the correct line that the error is on, but you slowly over time will learn how to interpret them and correctly resolve the wrong error. So we did that. Nested arrays, we did. Then we talked about one of the most important concepts in JavaScript, which is everything's an object, which isn't actually true. Not everything is an object. Data primitives are not objects, but most things in JavaScript are an object, like a good, sitting at 98% of things in JavaScript is an object. And now, you guys have worked with objects because you've done class-based programming, right? You've done object-oriented programming before. So you guys know that objects have properties and methods, right? Or maybe you guys call them data members and data fields, whatever you call them. They have the ability to, you have functions available on them and you have variables available on them to store data or to actually execute an action. Now the thing in JavaScript is instead of you guys instantiating these objects, they already exist. These objects are already there. They tend to happen immediately the second you go to try to call something on them, especially if it's like a string or an array. They just all of a sudden are available to you and you gain methods and properties available on those things. And that led us into basically testing an array length to let us know how many elements were inside the array. We use the length property, which stores the number of elements in our array. We also talked about adding elements using push and also using unshift. And we talked about removing elements using pop and shift. And then we talked about being able to add or remove elements to specific locations within our array using splice. Okay? Those 5 methods are pretty easy to work with. They don't require a lot of knowledge about objects, but today we're going to do some interesting stuff with callbacks, which takes it to the next level. Then we talked about loops, iteratives, and repetition structures, whatever you want to call them. We talked about the while and do-while loops, which you're not going to use a heck of a lot. Like they tend to show up in video game programming because of the infamous game loop. But for the most part, it's not very often you write while loops. You will write write while loops if you're doing basic PHP programming or working with the MySQL database, because you'll use a while loop to query over the fetch associated rows. But if you're using an ORM, it's not very likely you'll use a while loop. For the most part, for loops tend to do the job. I basically only use for loops because either A, I know how many elements I'm iterating through, or I can calculate how many elements I'm going to be iterating through. So I generally use the for loop structure. JavaScript does give us some other loop structures. It gives us the for of loop structure as well. The for of loop structure basically pops an element. Well, it doesn't actually pop it because it doesn't do anything destructive. It basically takes an element from the array and copies it into this variable. And then you have access to that variable within the block. And you can basically reference it directly as opposed to having to use the index number, right? And that was it in a nutshell. I find it funny that like you can cover this in 13 minutes, but the first time you teach it, it takes like 2.5 hours. But yeah, that's basically it. Does anybody have any questions about arrays or loops or conditionals or anything from last week or the week before even? No? Okay. I believe you. So let's move forward. So now this lesson has some wonderful things inside of it where you got pop-outs and stuff like that, and I've gone through and added in some nice highlighting and things, and it's really interactive that way. However, you guys had to program inside your IDE, save it, and then refresh, right? And then the refresh would cause the browser to update and give you some feedback inside the console, letting you know if something was wrong or whatever, right? So on the weekend, I took some time, and I mean like a lot of time, like pushing 20 hours on the weekend, and changed it up. So now you don't need your IDE anymore because the IDE is now embedded into the browser directly. And the reason why I did that was I can actually give you up-to-date evaluations on what you're typing in there, including syntax. So I can let you know if your syntax is incorrect directly. I can run your functions when you define them. I can evaluate your variables exactly as you've written them. I get a lot more control over what you're doing with your code, and I can give you a lot more insightful information about your code as we're going through. Then when we're done, we're going to click this Get Code button, and it'll spit out your code. You'll copy it and paste it into the submission field inside the lab, and yay, you will have submitted your thing. That's about that. So today we're going to talk about library and custom functions. Wow, that almost came out wrong. But first, we're going to talk about concatenation. Now, you guys have done concatenation, I'm sure, but I feel like it's a necessary conversation. So when you, believe it or not, when you take two numbers, right, say 1 plus 5, this is concatenation that's occurring here. This is happening. The whole concept of concatenation is merging two things together, right? You're merging them. Of course, it spits out 6, though, right? But you are merging these two items together. However, generally, when we talk about concatenation, we would assume that this would equal 1, 5, meaning it would take the two numbers and just put them side by side. That's usually what people associate concatenation with. But that's when you're working with strings, right? When you're working with strings and you concatenate two strings together, or you concatenate a string and a variable together, any value basically concatenated to a string will cause the two to become combined and basically become one big string. It's one of those things that I find more difficult to try to explain to people than to just demonstrate. Demonstrating it just seems to be a lot easier, works a little better. So if you take a look at the example here, you'll see that we set a variable called price. And underneath we have the subtotal. And if you look at the subtotal, it says the price of the product is $sign. Now that's because I want to keep my price variable normalized. I still want it to maintain, I still want it to be a number. I don't want it to change from a number to a string because performing calculations on it becomes more difficult. It's just much easier if I keep it as a number. But when I want to tell somebody how much something costs, obviously I want to be able to format that so that they can see they can have some syntactic sugar like the $sign, right? So the easiest way to do that is by using concatenation, where I can say the price of the product is $sign. However, I can keep this as a number. The plus number will actually take 17 and concatenate it to the end of this line, making this the price of the product is 17. Remember how we talked about the ID or the console? We can actually test that. You can just take these two lines, highlight them, copy them, paste them over here, and hit enter. It's going to say undefined, but now you can spit out subtotal, and you can see that it says the price is $17. It doesn't attempt to add it. Like, it's not trying to add these things together. It is concatenating the one value to the other. With concatenation, you can also perform evaluations as long as you wrap them. It's very, very important to wrap them. In this scenario, it would work because, programming follows BEDMAS, right? If you don't know what BEDMAS is, basically multiplication happens before addition, right? So these two numbers would multiply, then the result would be added into this, but that's not always the case. Maybe you want to add these things together, and if you were adding these things together, what would happen is you would first concatenate this thing on, and then you would try adding the price to it, and it would just wind up concatenating it on. So basically it would come out as the tax is $17 0.10, which is not what you want. You want the actual equation to occur. So we wrap it in parentheses. The parentheses, the first part of BEDMAS, brackets, right? Basically, this becomes evaluated first. The result of this now gets concatenated onto the tax is $sign. So if we want to see what that is, we can literally just copy this line, paste it in here, type with tax so we can see what it spits it out, and there we go. We got a very non-human friendly number. That's basically due to the fact that JavaScript does, like most languages, does calculations with floating point notation, and we're using base 2, so when we're using base 2, the calculations don't always come out the way you would predict them to. There are ways around that. We'll talk about that in a bit. So the same thing with the total. We can actually also put concatenation around it, right? We can have this string here, then add this equation in the middle, and then add a final string at the end. As long as you have the plus signs, you can concatenate continuously. You concatenate until you run out of memory, right? You just keep concatenating, but you just have to remember these plus signs. I marked a couple of labs for Monday, and that seems to be the common thing people are forgetting is the plus signs, right? My evaluation will tell you if you forgot it. So you want to make sure you have those plus signs in place. And like I said, if we want to see whether or not this works, go ahead and just copy it, paste it, hit enter, and then type in total, and you will see that the calculation actually occurred. So $1.70 is added on to $17, and it becomes $18.70. And fractions of a penny. Any questions about concatenation? All right, why don't we give the first practice a go? So there's 10 practices in total. These are built-in IDEs that you can use right directly inside your browser. Now, for those of you that are like, well, how does this thing actually work? In the background, under application, there is local storage. I store these into local storage for you. So I'm going to clear it. So don't feel like you can't refresh your browser. You can totally refresh your browser. That's fine. Your answers will be saved and they will store back into it. When you refresh, it will populate it with your answers. Okay? So no worries about if you actually refresh. No, I refreshed just so I could clear this. There we go. Just ignore this slow network crap. I'm going to change. I never find this stupid thing. I think I need to pull this out more so I can see the default levels. I don't want warnings. There we go. Okay, so the first thing says step 1. set your age in the variable below. So just put your cursor right directly inside this little box, and you'll see it blink. And then you can go ahead and hit space, write an equals sign because we're assigning, and then however old you are. So I'm 40. Next week I'll make it so you can hit Command S or Control S to have it auto-evaluate, but for now you can't. For now, it's just the way it is. Set your name in the variable below. Go ahead and do that now. Go ahead and set your variable in the next one, right? This is all the way back to week 1. If you forget, load up Module 1. And make sure you put it in quotes, right? Because it is a string. If you don't wrap it in quotes, what are they? Yeah, they become variables, right? Undefined variables that you are now trying to use. Yeah.
I typed my name in with like quotes, but on the console it's giving me an error saying unexpected string.
For what, though?
Oh, for like step 2 for the variable name, I put my name in quotes as a string, but
So you said let name equal and your name, exactly as I've got written up here?
yes, just my first name, but it's in double quotes, so just like up there.
So let me see what you mean. Let name equal. And age is infinite. Try hitting Control Shift R on your keyboard. Yep. Go ahead and hit execute again. All right, we'll take a look at it at the break. I have a funny feeling it's just a minor glitch. Might be a race condition with loading. All right, so for the bio part, we're going to use a concatenation. You must concatenate name and you must concatenate age. You can write whatever you want, but those variables have to be within the concatenation. So just do space equals, and you can write whatever you want. I'm just going to be nice and lazy. And then when you're done, you can hit execute, and if it worked, it should say passed. If it doesn't say pass and it gives you an error, that's fine. We can always take a look at your error if you can't resolve it at the break. I find if I wander around solving people's errors, it makes class go super, super slow. Especially considering 90% of the time it's syntax errors. All right. So that's concatenation. That's pretty basic. Like it shouldn't be really new. You guys do concatenation in your other languages, I'm sure, right? So it shouldn't be new. All right. Oh, every so often my mouse disappears. There we go. String interpolation. So concatenation is awesome, but string interpolation is awesomer. String interpolation basically is the process of taking a string and evaluating everything inside the string. And there's cool little syntax that you can write in there that says, hey, everything between these two things needs to be evaluated as an expression. So you get to avoid concatenation altogether, and you can put your expressions right directly in the string. Now, in some languages, that's done through like double quote characters and using like a hashtag curly brace kind of combination. But in JavaScript, we have a specific quote character that we use for this, and it's called the backtick. Now, incidentally, a student from Monday was using a Turkish setup on their keyboard, and their backtick, they couldn't find it. They didn't know where the backtick was actually located, and it took them a bit to find it. So if you are using a different language keyboard, it may be the same issue. I'll write down what it looks like. So here's my key. Okay? And you'll see it has a, just need to look at the direction, has a tilde, right? The tilde is the curly, the little curly kind of dash. The backtick goes like this, kind of. That's the backtick. Okay? So it's not an apostrophe. Okay, very clear. It's not an apostrophe. So you have 3 quote characters altogether. You have a double quote, a single quote, which is usually the apostrophe, and the backtick. Okay, so the one you want is the backtick. And the way it works is the whole string gets wrapped with the backtick, and anything you want to evaluate as an expression starts with a $sign and gets wrapped with these curly braces. Okay, so it creates this shape. Okay, and then anything in here will be evaluated as an expression by the interpreter. So again, let's do a test with that. So now if you hit execute and everything is okay, it should have copied your age and your name to the next practice thing. If it didn't, make sure you copy those 2 variables because you will need them for the next thing to work. And we're going to write the same bio basically that we did before, only we're going to do it with the backticks and using string interpolation. So I'm going to press my backtick characters and they're going to show up. And remember, this is the backtick character. Okay? So I'm going to write name like that. It's going to evaluate that variable inside there. Is age, and we'll just make it a little different, years old. Also helps if we use an assignment character and make this whole thing equal to it. 5 marks for me. Basically what's going to occur in there is it's going to say, it's going to take that interpolation, it's going to immediately evaluate this and replace this with my name. Then it's going to evaluate this and replace this with my age. Then it's going to return this whole thing as a string. Okay? So we'll say Sean is 40 years old. And if I want to see that, I'm going to execute it, but I'm going to show you something interesting. It says passed. You can also write directly in here, because this is an IDE, you can write console log bio, and then click execute. Why is my mouse skipping about? Stop. Stupid mouse, stop. There it goes. Wow. Execute, and you should see the console log spit out. It's great. These are full-fledged IDEs. There is missing, syntax highlighting, but I can add this stuff later on. It's just not available currently. So I might add it as we go. I might even give you the ability to choose your own theme. All right. Any questions about concatenation or string interpolation? No? Cool. Let's move on to library functions. So functions are essential, right? When you're doing like dry code stands for don't repeat yourself, right? They're absolutely essential when you want to create maintainable modular code. And it's not even just about maintainable modular code. It's also code that can be extracted to meet a different business case or a different use case based on a set of arguments that are passed to it, right? Functions are absolutely important, and it's important that you understand how they work. And they usually come with 2 things. So there's parameters and there's arguments. Parameters are what we define our function as having. They're basically placeholders, right, within our function that are waiting values. And arguments are what we pass our function when we call it. Okay, so there is a difference between the 2. Just so you're aware, objects have functions available to them, as you know, but generally they're called methods. And they operate essentially the exact same way. Just so you're aware, when you actually create a function in JavaScript, it becomes a method on an object. instantly. It becomes a method on the window object, actually, which is always there. If you ever want to see what the window object looks like, you can click in here, just type in window, hit the dot. These are all the wonderful methods and properties that are available on the window object. It's pretty massive. It's a big part of your DOM. All right. I even wrote a little bit here so you can actually see it. If you were to copy and paste this in, then you can hit window.x and you'll see the variable that you defined, and window.add will show you the function that you defined. Cool. So library functions are functions that come with your code API, right? So depending on what language you're working with, like Java, for example, comes with a math library, I'm sure. C++ actually comes with the standard library, which contains things like strings, because it doesn't have strings that are native to it, math functions, stuff like that. JavaScript is no different. It comes with a whole bunch of libraries, including for advanced math, right? So when you want to do things like absolute, ceil, floor, square root, round, any of that type of stuff, it has a library for that. Has a matrix library, has a whole bunch of different libraries built in, including for audio, text-to-speech, geolocation, whole whack of stuff that just comes as a part of the actual API. And I'm going to call those library functions, right? Basically meaning that they're just a part of the initial library. So one of the first things that I like to talk about is casting. You have casting in multiple different languages, right? But casting in JavaScript is done with these functions. And the reason why we use casting is because JavaScript is a loosely typed language. And a lot of people get kind of caught on this. Like, for example, let me just drag this out a little bit. Here we go. So we talked before about how 5 can equal the number 5 in JavaScript, right? Now I'm doing it. So I can actually test that if I say 5 is equal to, quote, 5, so string 5, right? It's true, right? And incidentally, that continues on into math functions as well. I can say 5 times, quote, 5, and it will say 25. So it's actually performing math. It's evaluating the number inside the string and returning it back as a numerical value and performing a calculation on it. Pretty cool. I can do 5 minus, quote, 5, and I get 0, as you would expect to, right? Or I can do 5 divided by, quote, 5, and I get 1. Here's where things go sideways. If I go 5 plus, quote, 5, I get 55. And the reason is because it identifies this as a string, and now it wants to concatenate the number to it, basically taking the two things and putting them together just like you would with any other string. That definitely catches people, like all the time, because they're not expecting it, because all these other equations work just fine, except for that one. That one does not work, right? So we need casting to normalize our data. Something you should always be considering when you're programming is normalizing your data. If you don't know for sure that it's a number, you should be casting it to a number. Okay, so that way it's a guaranteed to be a number. Especially when we're working with data coming back from the user, from the client, right? Because anything they type inside their little input boxes actually get treated as strings when you send them back to your PHP server or whatever server you're sending it back to, unless you're working with Node. But for the most part, it comes back as strings. So if they're working with their age, for example, and they type their age in, and you want that as numbers, then you've got to make sure you cast that. Otherwise, it's going to be a string. So we have some casting methods available to us. There's more than just these two, but these are the two that are the most common. There are ways to cast to Boolean, there's ways to cast to array, and there's ways to cast to objects as well. However, these are the two most common castings that you're going to see. String actually has two different versions for casting to string. You can do it this way, where you say string and then give it an argument. Or you can also do things like 5.toString. That also works. Okay. It has 2, and number has 2. Number has this one, and then it also has parseInt and parseFloat, where you can actually parse that string into an integer or float. But these are definitely the more common ways and common methodologies that you'll see here. Okay. So for the first one, we're taking the Boolean true, and we're making it true, right? So now it's no longer a Boolean, it is now a string. We're taking, in the second one, 5.45, and we're casting it into a string of 5.45. So it's no longer a number, it is now type string. Down here, we're taking the numbers and we're converting them from their string value of 0.46 into the number of 0.46. And then the last one, we're taking Sean and we're trying to convert it to a number. This results in something called NaN. And NaN stands for, does anybody know what NaN stands for? Exactly, not a number. Which, ironically enough, NaN, right, is not a number, right? But it is. So NaN is not a number, but it is type of number. So, yeah, so just keep that in mind. If you do quote something that does not resolve to a number, then it will return back NaN. Not that that's a big deal because it does come back as a number data type. All right. So let's play around with that. Let's use casting, and then after this, we'll take a small break. All right, practice 3, casting. If everything is gone to plan, age should be there on line 1. If it isn't, you'll need to add it. Step 5, using casting, add 10 to age and store it in the variable below. You must complete the previous question first. So we want to add 10 to age and store it. Does anybody want to tell me what the syntax is going to look like? Yeah, equals age.
No.
Yeah?
Number, bracket age, plus
Nice catch. Yeah. I'll show you both of what's going to happen. So it's not going to execute yet because we're missing one of the steps. If you do number age plus 10, it's going to spit out, it should spit out your age plus 10. So I'll put it on the next line. We'll just do console.log age plus 10, so it's there. And then I'll execute it so at least you can see it. And you should see the number, your age plus 10. But if we were to forget the number casting, you're going to get 4010 if you're 40 years old, which you're not. You're probably going to get 2010 or 1910, depending on how old you are. And that's because of concatenation. It's not actually adding the two values together. It's just placing it at the end of it. It's concatenating it to the end. All right, so make sure you wrap that in number. See, now it annoys me that I have end brackets. All right, so using casting, you're going to fix the condition and make the following execute. So what do we need in here in order to make this true?
change boolean to string.
So we're going to change the Boolean to a string. And what function are we going to use to do that?
String and
Right.
bracket.
Now, I'm not sure if this will work. I'm going to try this. Oh, nice. You can highlight and hit your bracket, and it'll immediately wrap it in the brackets. And if that's good, just hit execute, and it should say passed. All right, that's practicing for casting. Pretty easy, string, number. And these little logic problems will show up on the midterm in another 3 weeks. You will see them. So just keep those in mind. I like to throw a couple of those on the test just to kind of throw you off a little. Yeah, mate.
Can you go
That far or further?
where we had the windows for add?
Where we had this thing?
Yeah. What if you want to execute the function, not just the function and the function?
So if you want to execute that function, so if we copy this and paste it, and then you do window.add, it's going to spit out the function definition, to execute the function, use the execution operator, and it'll execute the function. Which kind of reveals how extremely powerful function definitions can be when you can just pass around the definition as a value and execute it when you're ready to execute it, right? All right, cool. Why don't we do browser dialog functions and then we'll take the break because it's going pretty quick. I like how fast it's going, actually. It's nice. All right. These next three functions aren't used often but are important to know about. So they are the dialog functions: alert, prompt, and confirm. The only one that I tend to use in my day-to-day is confirm. It's like literally the only one I use. I don't use alert because I find people that use alert are just being jerks, right? It's a jerk thing to do to just like force this person to dismiss this thing. There's only very specific reasons that you would ever do that, and I can't think of them off the top of my head. And then prompt is basically used for bringing in user feedback. So if you need to set a value or something and you need like a response from the user instead of using an input box like a normal human being, if you want to use prompt, you use prompt to bring in their feedback, and then you can use that value inside your JavaScript. And confirm literally returns either true or false. That's it. You get a Boolean value response of true or false, which I use often because when I ask the user, are they absolutely sure they want to delete those 14,080 records? Are you sure? Right? Then at least I'm covering my butt because, either they hit yes and deleted the 14,080 records, or they disabled JavaScript, and that's their problem, not mine. So that's the other thing. So these are the three dialogues that you're going to see: alert, prompt, and confirm. And this is an example of how they're used. So alert is like a one-way message. There's no response back from the user except for the ability to dismiss it. You can't even tell if they have dismissed it. All you can do is send them alert. This uses the browser dialog, which is a built-in system. No dialog is going to look the same across browsers, across OSs, right? So, for example, the dialog box in Chrome browser on a Mac will look different than the dialog box in the Chrome browser on a Windows machine versus a Linux box. They look different because it's the browser itself that controls the implementation, and quite often they'll use the Windows dialog library that's in the background, right? You guys have done stuff with that, I'm assuming, in Java. You've used like the built-in Windows dialog boxes and stuff. Yeah, so the GUI library or whatever it's called. It's no different with Chrome. They're using that same library in the background, right? So they look different. They're not necessarily going to look the same on Safari. It's nice and pretty. On Chrome, it's a little better. Firefox needs to get out of 2002, but for the most part, it's fine, right? You're not going to use them often enough. So the response one, the prompt here, prompt is meant for two-way communication. It's you giving them a message and asking for some sort of response, but your response comes back as a value, right? And it can be any value that they want, string, number, whatever, it doesn't matter. They just return back a value. However, when you get that response back, it is always a string. If they write true, it's a string. If they write 5, it's a string. It's always a string. Never fail, it's a string. So that's where casting would come into play if you were going to use that for any reason. And then confirm. Confirm always comes back as, it is like two-way communication, but you're always going to get a yes or no response. That is it. You're not going to get any other answer except for true or false. Those are the only two answers you can possibly get from it. And like I said, it's definitely something a lot of people will use in web development if they're dealing with CRUD operations and the user is performing CRUD operations. And because CRUD operations minus read can be destructive, you're going to want to confirm some of those operations to make sure that's what they want to do. All right. Yes?
Do you need to write late before alert?
Do you need to? No, because you're not storing it. There's no response.
Okay.
All right. So alert. Actually, I don't even know what you would get if you did that. Let's let A equal alert. No response. Cool. A. Yeah, it's just undefined because it doesn't return anything. There's nothing in it. All right, cool. So let's use these fun things. All right, using the correct dialog method, inform the user about an important message. So what dialog method am I going to use? Alert, right. Alert. Your base all belong to us. There we go. Cool. And if you click execute, you will see that alert pop up. Execute. And it should say whatever you wrote in your message. Okay? Just ignore the error message just because we haven't filled out the rest of this stuff yet. Incidentally, that is definitely senior size. Make that a little smaller. All right, using the correct dialog method, ask the user if they wish to modify future messages. What am I going to use?
Confirm.
How many people say prompt? How many people say confirm? Okay. Why does confirm make more sense than prompt in this scenario? Exactly. That's the best way to know which one to use. It's a yes or no question. I need no other information from that person. I only need to know yes or no. Yes, do you want to do this? Or no, you don't. Right? So we're going to use prompt. And because it's prompt and it returns a response, I need to store that response. Right? So you can call it whatever you want. You can call it response. You can call it choice. Whatever you want. I'm going to use choice. Prompt. Do you wish to change this message? Well,
It's not prompt.
what's that? Oh, sorry, not prompt. Yes, it is. It's prompt. Oh, no, it's confirmed. Sorry. Yeah, it's confirmed. My apologies. There you go. Yeah, it's confirmed. Yeah, right. Are they closed? Yeah. Just go through the labs link so I don't have to do it underneath the weekly assignment, Rick. The hell is it? There it is. There you go. This should be open. All right, so for the last one, using the correct dialog method, ask the user to enter the new modified message. Now, don't jump yet. There's another piece to that. To enter the new modified message they wish to have used if they've chosen yes to step 2. So what is my syntax that I need to use here? Sorry? Yep, if statement. What's the condition?
Choice.
Perfect. If choice is equal to true, and it's a Boolean because it will return an actual Boolean. It's not string true, it's Boolean true. And then what am I writing in here? Yeah, we're going to use prompt. We should store it. Because, I mean, what's the point in asking them for information if we're not going to store the value? Right? And we'll just say, what is your message? And then hit execute. And we have to do this twice. Okay, so there's 2 tests that we have to run. One where we basically say no, and the other one where we say yes. Okay, so your base all belong to us. Okay. Do you wish to change this message? Sure. What is your message? Well, I'm super lazy, so it's ASDF. Cool. It will tell you over here that it is passed, the first one. Click execute. Your base all belong to us. Okay. Do you wish to change this message? Cancel. That's the false side. And you'll get pass because now you've passed the second test. Alrighty. Yes?
In the code, do you need to actually put 3 equals? Can you just write choices in the bracket?
Yes, you can. You could definitely shorthand that and write choice. Now, I don't know if my code will allow it. It might not. That one passed. I'm thinking it doesn't because based on what I just saw that response as. Yeah. No, I guess it does. Yeah, that's totally fine. My code does allow it. I wasn't sure if I was actually looking for the equals Or not. All right. Let's take a small break. Regroup. We're moving along pretty nicely. I mean, we're on practice 4. There's only 10 practices. We might get through this pretty quick. That'd be nice. I modified this slightly. Just made a quick change to something. So if you hit refresh, that's totally fine. All your values are already saved. So we'll just put your values back in. The one thing it won't do, though, is wherever it said passed, it won't put that back in. You'd have to hit execute again. Not that it matters. It doesn't affect anything in the end. It's really just for you to know that you passed that particular part. So if you did have problems, you may want to refresh and try that. All right, math. We didn't talk about this in week 1. I think the next time I teach this, I'm going to move it to week 1. I'm trying to make sense. Just put all the operators in week 1. But we should talk about operators. The thing is, though, is like when I teach this to web students, I'm not saying they're not as capable as you guys, but they're definitely not more programming interested, right? A lot of them join web and want to do design. That's what they want to do. They want to design web pages and use WordPress and Divi and Shopify and stuff. Nice, easy stuff, right? You guys, you're programmers, you're hardcore, you want to do hardcore stuff. So these operators, yeah, they're just recaps, right? You guys know what an operator is. You know how to use math operators. You know how the plus sign works. It adds 2 values together. No, not a chance. No. No idea how the plus sign works.
Brand new information.
Brand new? Okay, well, the plus sign. We'll take 2 numbers and add them together for you. The minus sign will subtract the right side from the left side. It's very specific, too. It's the right side from the left side. All right?
It can't be the other way around.
If I turn around, it is. The right side from the left side. Right? The division is performed using the /, right? So if you're used to this character, be used to it no more, because now you must get used to this character. All right? So the / does division. The multiplication sign does multiplication, obviously. So it will take the left side and multiply it by the right side. Not that it matters, right? Because they're inversible. Now, the only one that I do find that some people are brand new to is the modulo. How many people have never heard of modulo? Just out of curiosity. Really? That's pretty cool. But you had a good programming teacher. Or you learned it in school, right? This character is fantastic. What does it do? Exactly. It returns the remainder from a division, right? So if you take 8 modulo 3, right? So you're essentially dividing 3 into 8. What will modulo return? 2, exactly. Yeah. Now, you may be like, well, when would you ever use this, really? This is not really something you use all that often. You'd be surprised. In web, specifically design, you use it a lot. Like, you use it a hell of a lot. And the reason why is because, say I want to put 3 products in a row. And then the next line, I want to put 3 products in a row. And then I want to put 3 products in a row. Well, with modulo, I can be, does this divide by 3? No. Add it to the next one. Does it divide by 3? No. Add the next one. Does it divide by 3? Yes. Cool. Move to the next row. And I can keep doing that using modulo. Modulo is fantastic for that. Now, granted, if you're using Bootstrap 4 and Flexbox, you don't need modulo. But modulo is great on older legacy systems.
I was going to say, I think that Bootstrap now, they actually use it nowadays.
No, because they actually switched over to CSS Grid. And CSS Grid does that behind the scenes, right? So you don't need to do it. It's just done for you. And responsively. So, yeah. Cool. But those math equations, those math operators, they're basic, right? They're super, super basic. They're not for complex math. If you want to do complex math, you're going to use the math.squirt, which is actually square root, but it looks like it spells squirt. It's not. You're going to use math.ceil, which represents ceiling, right? That's for rounding up always. Doesn't matter where the midpoint is, you're always rounding up. So if it's 10.6, you're rounding to 11. If it's 10.2, you're still rounding to 11. That's just the way it works. Floor, math always rounds down. Doesn't matter if it's above the midpoint, it always rounds downwards. So 10.5 would translate to 10. Round Round will go based on the midpoint. So if the midpoint is 0.5, it will round up. If it's 0.4, it rounds down. And random's the one that people find very bizarre, because if you use C++ or like a C++ kind of base language, the rand function will return anywhere between 1 and 4 bytes. Yeah, which works out to 32,000, I'm going to get it wrong, 652 or somewhere around there. It's like some random number. But yeah, it's like 1 between this 33,000 number, right? Whereas JavaScript returns between 0 and 1. Now, you're not going to get 0 or 1. You will get 0.00123, and then the next time you'll get 0.123. You'll get some version of that. And because of that, it makes this thing really, really powerful, because this actually returns back like 9 digits. It's like an unsigned int. I'll show you. If you do math.random, it's just a function call. You do that. See? Like, how many numbers are there? 5, 10, 15. 15 decimal places. That's super cool. That's like a very random number. So you could potentially, if you multiply this whole thing by whatever number is a 1 followed by 15 decimal places, that will turn it into a whole number, and you now have 1, 2, whatever that number would be. Is it like quadrillion, quintillion, or whatever? It's ridiculous. So yeah, no, random is awesome. Random is an awesome, awesome function. Okay, so why don't we play around with these a little bit. Use the correct math function. Step 10. What is the square root of the following number? Okay, so the first thing we need to do is access the library, which is called math. Math is an object. Surprise, surprise. Almost everything in JavaScript is an object, right? And the math object has a function on it called square root. So it's SQRT. Just remember squirt. That's an easy way to remember it. And then that is a function. So I'm just going to highlight this and go boom. There we go. It's wrapped in the parentheses. Oh, don't hit Command S. Or you'll save your web page. Cool. So if you want to test that, obviously you can hit execute, but it's not going to really help you. So just write a console log underneath it. And just put an X in there. Hit execute, and it should say 8 if it worked out, right? And incidentally, the evaluation script won't tell you if it passed, but it will tell you what the next error is. And it says, your rounding down syntax is incorrect, which is obviously talking about step 11. So it's not the step you're on. All right, so round the following number down. Which one of the math methods do I want to use to round down? That was a bunch of different answers. How many people say seal? How many people say round? Almost got you. How many people say floor? There you go. You've heard that old adage, right? 1 tequila, 3 tequila, floor. Not funny, eh? Bad experiences with tequila. All right. Math.floor. Again, you can console log that if you don't believe me. Just a filthy liar. Execute. Sure enough, there we go. 10. 10.9 translates into 10. All right, you guys do the next 3. Next 2, at least. Next 2. We'll do the third one together. I'll give you a minute. So the next one, you're rounding up. And then the next one, you're rounding based on the midpoint. Go ahead and type it in. Hit execute. See if you get it. Should definitely pipe this through an API. Put it up on the screen and show statistics of right and wrong answers. That would be cool. Might do that. Sounds like a fun project. All right. Everybody done? Anybody not done? Just one person. All right. I'll wait. Anybody get it wrong the first time they tried? No? Not going to admit to it? All right, cool. What is the answer to step 12? Anybody? Yep, seal. There we go. And we can test that, right? Console.log. Get in the habit of doing this. Just so you know, if you don't have to just spit out W, because sometimes that doesn't tell you a lot of information. So you can write something beside it. So I'm going to write seal. And then you just put a comma beside it, and then the next value, and you can give it a list of things you want to console log, and then execute, and then you'll see seal 11. So that way you know that that value belongs to seal. And then what about step 13? What's the answer to step 13? Yeah, math.round. Boop, boop. Bam. Console.log round. There we go. Execute. Cool. So far, so good. Currently says T is of type undefined. Did anybody do the last one? Yeah. What is it? Equals math with a capital M dot random. And it is important. I don't think math dot random will work. No, it will not. So the case is sensitive, right? You got to remember that. Case is very, very sensitive. Hit execute, and if everything's good, it should say passed. If you want to see the value of T, just do console.log. I'm going to write random so I know which one it is. T, execute. Mine came out to 0.18, right? Incidentally, your assignment that I'll bring in next week will be generating a random number between 1 and 100, and then making the person guess that number between 1 and 100. I don't know how much of it I'll do for you, and then you just put in the functions. Likely that's the way it's going to be. You'll just write the function that I want you to write, and then I'll test against your functions. So. All right. Any questions about the math? No? Incidentally, there is way more than just those few that we did. If you type math in your console and type dot, you can see there's all of these different math functions that are available to you, including log. There's matrix math in here as well, I believe. There's pow, tan, and tan-h. There's a whole whack of different things that are available to you from the math library. So if you're pretty skilled with math, you might know what some of these are. I know about 10 of them, and that's about it. Atan I know. Atan 2 I know. Atan 2 taught me because I built a video game, and I had a little ship, right? And it would follow your mouse, right? But if you brought your mouse too close to it, it would go into something called Grimble lock, where it wouldn't turn the way it had to turn. So Atan fixes that. You give it a degree, and it fixes it so it turns in the correct direction. I'll share it with you guys at some point, the video game. It's crap, but you can play it. All right, cool. String. There are numerous string methods, and we can see that if you type in string dot. You can see there's a whole bunch of string there's a few. There's like 15 of them, right? However, there's only a few that we actually really use a lot, and that is to uppercase, which obviously takes all the letters in the string and makes them all uppercase. To lowercase, which is the opposite of that. There's replace. Replace takes a pattern. You give it a pattern. So for example, if it was hello world, and you wanted to say goodbye world, you would give it the pattern of hello, and then you can give it a replacement value. So you would say hello, comma, goodbye, and it would replace every instance of hello with goodbye. Okay? That's replace. There's index of, which will tell you the first instance of a pattern. So if, for example, hello world, it would return back 0. It's literally the starting index of where it finds whatever it is you're searching for. Okay? If you want a little bit more information than just the starting index, and maybe you want back matches and stuff like that, you can use match. Match will return back matches of the word that it finds as well as the index number that it starts at. Match is basically useless if you're just going to pass it strings, but it is stupid powerful if you're going to use regex, right? And for those of you that don't know, regex stands for regular expression, and I do recommend learning regular expression. It is language agnostic, meaning regex can be used in every language, and it is extremely powerful in the fact that it's what's powering my evaluations. So when you guys are getting your scripts evaluated by this system that I built, it's regular expression in the background that's doing that. All right. I think I missed one. Trim. There's also trim. Trim basically strips white space off each end, right? So you can see the different examples. If you do uppercase, here's Sean McKinnon to uppercase. You take your string and you call the method on it. So that should tell you string is what type of thing now. What would it be? It's an object, right? Because now we can call a method on it. It's become an object. So we can call dot to uppercase on it, has that method, and it converts everything into uppercase. Down does the reverse of that. Trim will take away all this white space before and after. Replace, so here's Sean replaced with Dave, so it changes Sean out to Dave. And replace is case sensitive, just so you're aware. If you want it to be case insensitive, you'll have to use regular expression. Finding first occurrence of, so let first Sean McKinnon dot index of McKinnon. It finds it at the 6th index, and you can count that 0, 1, 2, 3, 4, 5, and there's the 6th index of where it starts. Okay, and then matches. Matches will return back an array of. Actually, it's an array object, I guess. Must be an object. It's an array and an object. It's weird. Actually, I'll just show you because it makes more sense to just show you. So if you highlight that, copy it and paste it in here, and hit enter, it returns back this thing, which is basically an object. So you can see that 0 index is McKinnon, groups is undefined because there's no groups encapsulated. Index is the starting point of that search query. The input is what you actually are searching against. And the length is the total size of the array, which is silly because it's not really an array. But that's what it is. And we'll talk about proto in the future. Don't worry about proto. All right, let's practice. I mean, why not, right? Make your name uppercase. Now, this should have copied the name from above, but it did not. Yours may have. If it didn't, I believe all you have to do is click execute on 1. Yeah, I think it's on practice 1. It may be on practice 2. I'll just click both just in case. And then if you come back down to practice, what practice number is it? 5? 6? Ooh, we're already on 6. There we go. Practice 6. It should pop your name in there. If it didn't, make sure you can hard code it in. It's totally fine. All right. All right. Make your name uppercase. Now, you could cheat and just type it out in uppercase, but I'm pretty sure my evaluation script will tell you it's incorrect. Let's just double check that. There we go. Here's me being smart, thinking I'm a genius. Nope, you're missing the correct syntax to uppercase the value. It's looking for the function. So, all right, let's give it what it wants. So we're going to type in name, dot, and this is important. The snake case is not optional. You have to type it exactly as it is, which is 2, capital U, upper, capital C for case. And it's a function, so we have to give it the parentheses. If you don't give it the parentheses, you essentially assign the to uppercase function definition to uppercase, is what you would end up doing. And obviously, if you want to see that, you can go ahead and console log it out. Actually, we can even test it. p5.emb. Nope, p6. P. And, yep, there it is. Where is it? Oh, there it is. Upcase. Let's do downcase now. Equals name dot, and what is it? Yeah, to lower capital C ASE. There you go. Execute that. And if you did it correctly, it should tell you you're missing the syntax for trim. Trim, very simple. Just dot trim, opening and closing parentheses, because we're executing it as a function. And then the last one, don't let it catch you, because another student did this and he forgot the N in statement, and I came back and told him it was wrong. And he brought up his computer and said, it's correct. I'm like, no, it's not. It's wrong. So it's equals. You take statement. So you start with the string. It's dot. You do match. And then match takes a pattern as an argument. So the argument we're going to give it is world.
I have a question for the trim.
You have a what?
A question for the trim.
Yeah?
So what I did is like I put console.log
Trim?
trim.trim and it's put brackets again.
Right. So if you don't type this here, I don't know if I actually cover that. And you do trim.trim.
And console.log.
Yeah, it'll warn you. Yeah, it's because it's actually looking, it's trying to pattern match based on you adding trim to the end of it.
Oh, would that work?
Yeah. Yeah, 100%. Yeah, you can actually test that, right? So what you could do, just copy those,
Okay. And just
paste them into here, hit enter, and you'll see that it works just fine. Yeah. I'll try to make my evaluations less strict, because I think they're a little too strict.
Just a tap.
Just a touch. All right, so if everything's good, you should be able to click pass and everything should work. Now, like I said, match actually takes a regular expression or a string. So I've given it a string, but we could actually give it a regular expression. And I don't expect you to know what these are, and I will never mark you on regular expression. That's just not a thing that I do. But why don't we I'm going to take this string here and I'm going to copy it instead of typing it out. And we'll paste it. And then I'm going to do dot match. And we're going to give it a regular expression. So in order to signify that I want to do regular expression, I have to tell JavaScript that I'm doing a regular expression. And the way I do that is I use the slash, the forward slash. I write my regular expression in here, and then I end it with a slash. After this, I can give it something called flags. I can tell it to be greedy, which means take this expression and keep doing it over and over again across the string. Or I can tell it to ignore case, which means it will ignore uppercase or lowercase. It won't care about it either way, right? Or I can just leave the things off. But everything else goes in between here. So I'm going to say I want to match world, for example. So I do slash, slash. That tells it that it's regular expression. Then I type in what I want to match, and I can say world, just like you would with a string, only I'm not wrapping it in a string. And I can hit enter. And it will find all instances of world. Now you see this cool little thing here where it says groups, like this? What I can do with that is I can take world, and I can say, well, I want you to match world, but I want you to capture war, just the W-O-R. I want you to capture that in a group for me. And then I hit enter. And now you can see that I have world and a captured group of war. And I can do that throughout. I can capture little blocks of syntax and pull them back out as values using regular expression. Very, very powerful stuff. I would definitely take a look online and see if you can find, you know what, I might even see if I can find a good one for you and post it. And then you guys can go through like a little regular expression course. Usually take about a half hour or so. Takes years to get really good at it though. All right, custom functions. Do we want to do this or have a, no, we don't need a break yet. You guys don't need a break, right? You're cool? Okay. Writing a custom function. Creating our own functions. You guys all know all about why we create functions, right? Because it's modularity, dries up our code, allows us to do abstract logic. I mean, functions are fantastic. The only thing better than a function is a class method, right? Well, functions and class methods are exactly the same thing, and in JavaScript they're definitely the same thing. Just like variables in JavaScript, functions don't need to be data typed in JavaScript. So when you define it, you don't need to data type. You don't need to be like, this is a string because it's going to return a string. This is a void because it doesn't return anything. This is a number, float, sorry, integer, whatever, because it returns that thing. You don't need to do that. You just write your function, have some fun. That's all you need to do. All right, so let's take a look at what the custom function syntax looks like. It's very simple. If you've written functions in PHP, it's exactly the same. It is different than, say, C++ or Objective-C. I think it's different than Java as well. You guys don't have the function keyword, do you? In Java, do you?
No, it's not.
No, there's no function keyword. Yeah, so but we have the function keyword when we deal with that in JavaScript. This chalk is getting to be ridiculous. Like I'm basically writing with my fingertips. So essentially the way it works is we use the keyword function. That tells the interpreter that what we're about to create is a function definition. That is a very important word, okay? Definition. A function definition is simply the syntax that you've written your function with. That's all it is. That's a function definition. It doesn't become an actual executed function until we add a very common operator, which are these parentheses. That actually executes the function. Okay? So when we write our function definition, we write the keyword function, and then we can optionally give it a symbol name. You don't have to give it a symbol name. But if you don't give it a symbol name, how are you ever going to reference it? Right? But you don't have to. Does anybody know what it's called when you don't give it a symbol name? It's anonymous. Yeah. It becomes an anonymous function, meaning it's got no name, so you can't find it because it's anonymous, right? And you may be like, well, why would you ever create a function with no name? What is the purpose of that? And you're going to find out when we take a look at callbacks, why you create anonymous functions. So this is the opposite to anonymous. We're going to say anonymous. This is anonymous. No, that doesn't work. This is a name function. And these things here are called parameters. And I find that people that are new to programming, and actually even experienced programmers, I heard my boss say this the other day, and he's been programming probably for the better part of 25 years or so. He called these things, in this function definition, he called these arguments. He called those arguments. Are those arguments? Oh, the parameters. Arguments are when you pass the function, right? That's what an argument is. An argument is you're passing the function some value. Parameters, I think the best word to describe a parameter is a placeholder. That's really what they are. They're placeholders. They allow you to basically say, I'm going to put a value here. I don't have a clue what that value is going to be yet, but I know I'm going to need it. So I'm going to use a placeholder and basically use placeholders for my values. Now this isn't a very good demonstration because I've defined two parameters, but I'm not using them at all, but that's perfectly okay. You don't have to use them. I mean, it's not very efficient programming. And in some languages, like Golang, probably the worst freaking language I've ever touched in my life, but Golang, you can't do this. You can't define parameters without using them. It blows up and yells at you. Does Java yell at you if you define parameters without using them? It does? All right. Well, Golang does too. JavaScript doesn't care. Use them, don't use them, doesn't care. It even doesn't care if you call this function without those parameters. So if you don't pass arguments to fill in those parameters, JavaScript's not going to say a word about it. It's not going to warn you that you did something wrong. It's not going to tell you that you're missing anything. The only time it will tell you you're missing something is when you try to use these things and they're not defined. Then it's going to blow up and be like, those aren't defined. You have no definition for these things. Anonymous function, even though this is an anonymous function, this is a function with no symbol name. Has no symbol name whatsoever, right? And that is completely okay in JavaScript. And because this thing is called a function definition, because it is just the syntax you're looking at, you can actually save it into a variable. You can store that definition right directly into a variable. And then if I want to call this function, all I have to do call call my func, and execute it. That's it. I mean, how many languages let you do that? Almost none, right? JavaScript and PHP and Ruby, that's about it. Not very many languages let you do that. So it's very, very cool. And it comes in handy, and it's important to understand these two ways that functions are written because you will see this. If you pull down somebody else's code, so many JavaScript programmers like to do this one. They love doing this. They love doing let my func equal the function definition. I don't know. They just feel happy about it. But so you will see that quite often, so it's a good idea to be aware of it. So let's write a function. This one says, write a standard custom function called greeting. It should have one parameter called name. It should console log hello name using string interpolation. So we're using a couple of things that we've learned today. When I say write a standard custom function, I mean function, symbol name, parameters, just the basic way, not an anonymous function. We'll do it together just so you get the idea. So function, greeting, and you must call it greeting. I had a student on Monday ask me why we have to use those names. Obviously, my evaluation script is going to execute your function and look for its output, right? So you're going to write function greeting, takes one parameter called name, and then it's going to console.log using string interpolation. That's the backtick, right? Hello, comma, name in the interpolation. And there's our function. Now, we're going to do another one, only this time we're going to do it with an anonymous function. We're going to create a variable and we're going to store a function definition into that variable. All right? So step 20, write an anonymous function and store it in the provided variable. This function should have one parameter called message, and it should console log the message, this basically thing here. So why don't you just copy that because it's already got backticks in it. So I'm just going to go Command-C so I have it. And I've already done the first step. Let notify is already there for you. So let's write an anonymous function. Equals, not a scary thing to write. Just don't put a symbol name there because it doesn't have one, right? This parameter is message. Let's open a set of curly braces. Now, it's going to seem bizarre to see this curly brace at the end of the function, but that is completely legal. In JavaScript, that is perfectly fine, so you can leave it there. And then in here, we're going to console.log. Go ahead and paste that thing if you copied it. And congratulations, you wrote your first anonymous function. I don't know, I might be wrong. How many people here have written an anonymous function before? One. All right. Did you do it in a callback? Were you writing it in a callback? Yeah. Yeah, you guys are going to write tons of them going forward. All of our event-driven stuff, we'll be writing anonymous functions. Anytime we're doing like method things with arrays, you're going to be writing them. You're going to write one today. All right. So go ahead and click execute. Passed. And you should also see the messages show up in your console. Right? Hello name. The message is the message.
Didn't say fast.
Yeah. Can you? Does that work? Okay. I'm assuming it's the code you want to see. Yeah.
Didn't say fast on my.
It doesn't say pass on yours? Does yours look exactly like mine?
Yeah.
Did you use string interpolation? Because it checks for that. Uh-huh.
Mine says that.
All right, we'll look at it afterwards. Okay, are you good? You want me to go the other way? All right, there you go. No worries. At one point, when I found out I was going to be teaching this the second time around, I didn't complete it, but I had started to build a coding application that would allow you guys to type on your screens, and then I would see it on my screen using sockets. And then I abandoned it because it was overachieving. It was a little too much. I'm going to come back to it because I think it'd be a cool app. All right, are we good? You're not good? Okay. We'll take a look at it afterwards. Yeah. We're actually almost done, so we might as well just finish up, and then I'll just help everybody. You can do your quiz, send in your lab, that kind of stuff, work on other homework, whatever it is, right? Let's talk about calling custom functions. Calling custom functions, you guys have called functions. You probably called functions hundreds of times, right? And it's no different in JavaScript. The only thing you need to understand is that my func does not equal my func with brackets. These two things are not the same thing. This one executes and will do whatever logic is inside the block. This one is the block. It's the whole definition, right? That's what you get back. You get back the actual definition. And I'd like to demonstrate that in our console. Let's just write that function. So we'll do function my func, right? Give it a couple of parentheses. Hit enter. I'll zoom in a little bit so you can see. And all we'll do is just console log something out. Console.log.
Awesome.
Why not? Awesome. Whoops. And then we'll close it off. Cool. So there's my func, right? I've got this function called my func. And if I call my func with a set of parentheses, I will execute this function. So let's try that out. My func with a set of brackets. Awesome, right? But if I call my func without the parentheses, I get the actual function definition back. It returns the whole definition. Now let me show you something kind of neat. I've got my func. Now I've got a variable called x. And I'm going to make x equal to my func. But I'm not executing it. I'm just making it equal to my func. Right? This is the function definition. Now I'm going to hit enter. Now I can go x, set of parentheses, and I get awesome.
Also, you put the function in a variable.
I've assigned the myfunc definition to another variable. Exactly. And I can do that all I want. I can make an object property equal to that func, to my func. I can move it around, and because I have the ability to just take the definition and move it wherever I want, it gives me a lot of power over what has what has what functionality, what has what capability, right? I can also do things like pass entire functions into a function as a value. I can take a function and give it to another function if I want to work with. Those are called callbacks, by the way. If you use lambdas, you'll understand callbacks pretty quickly. All right, so we have examples of how to call functions, right? Calling functions, very simple. My func, if it's got some parameters, you can give it some arguments, but like I said in JavaScript, the arguments are totally optional. In here, no difference if it's an anonymous function. You call it exactly the same way as you would if it was a named function. There's no difference, right? As long as it's been assigned to something. Obviously, if it's not assigned to anything, how are you going to call it? It's got no name, right? But that's basically the way that works. Pretty simple. Let's scroll down here. I've copied over the two functions for you. So you've got both of your functions ready to go. Now we're just going to call them. And like I said, it's not difficult to call them. Let's go ahead and call them. I'm going to call this one greeting. And I'm going to pass it my name, Sean. And I'm going to hit execute. Hello, Sean. And then for the notify one, it's no different. I'm just going to say notify and give it whatever I want. It says to use the Falcon Fly South for winter, but I'm super lazy, so I'm just going to write ISDF. And click execute. And if everything is golden, you should see the message and hello Sean. And for some reason, I think my code is there, but it's gone below the bottom line here. Looks like I might have some CSS to fix. But it is there. I'm pretty sure it's there.
Wait, can you do it some line so we can read your code?
It's right there. Hold on. It's not as easy as you... Oh, wow. That's terrible for trying to do anything in. Hold on. Let me see. Inspect. That's the next line. That's not helpful. All right, I'm gonna have to hold on. There you go. We will need to fix these windows. I don't know why it hides the code.
So that's in like a primary and notify.
Yep. Because we take one argument, right? Now the argument is completely optional. And if you don't pass a message, what will happen is this would equal undefined.
Okay.
Right? But the problem is when you run this and you try to parse undefined, I don't know if it would blow up. It might not. It just would have nothing in it. It would just be empty, right?
Right.
Because parameters inside JavaScript are optional. They only become necessary when you are now using that parameter throughout your logic block, like you're trying to call to uppercase on it or something like that. You can't call to uppercase on undefined because undefined doesn't have that method available to it. So it would blow up and say reference error and stuff like that. All right. I'm going to click, you know what, I'm going to add a couple of lines and then click execute. All right, so let's talk about parameters and arguments very quickly. So parameters, right, those are the things that you use as placeholders when you create your function. When you define your function, you're using them as placeholders. In JavaScript, there's no data types. It doesn't care about data types. It also doesn't really care what you pass as an actual value. You can pass strings, you can pass numbers, objects, arrays, and functions. You can actually take a function and pass it as a value directly to your function, which is pretty cool and integral to asynchronous programming because with asynchronous programming, you don't always know when something is going to complete. And because of the way JavaScript works, things happen not in the order you're expecting. So things always tend to happen out of sync. How do I want to do this? I want to demonstrate it in code? Nah, I find it confusing. Essentially, let's say I have a variable called let response. Okay, so my variable is let response, and I have a method that returns back an API message. Okay, I'm expecting response to have this API message in it and ready to go. So if I come down here and go console.log response, this should contain the response from this thing that's occurred. The problem is in JavaScript is that's not how things work. What JavaScript says is, cool, where's another piece of chalk? I'm waiting for this thing to finish. And JavaScript says, hell's no, I'm not waiting. It can do what it wants, and when it's done, it can deal with its own crap. I'm moving on. And it immediately executes console.log. And this is empty. Has no value in it because this hasn't finished. It's not done. This is asynchronous at its most horribleness. This is what happens to a lot of programmers, especially programmers from Java, from PHP, from synchronous languages who expect things to happen in order, and they don't. And this can be extremely frustrating because it's not happening in order. So usually what happens, a good programmer will give you the ability to change this up a little bit. And they will allow you to pass in a callback function. Whatever function you want, doesn't matter. Why don't we give it my func, right? We'll give it my func. Okay? So now it's got my func. So when it's done its API call, it's going to call my func, right? So then I have my function defined over here. Cool. This thing, when it's done, not only is it going to call my func, it's going to pass an argument. It's going to give it an argument, right? So I better have a parameter in order to take that argument. And you know what? I'll save myself a lot of hassle for readability, and I'll just call it response, right? Create my block. Now I can go ahead and console.log the response and let it finish. So here's what's going to happen. I know. I totally get it. API message my func is going to execute. And when it's done, it's going to execute my func. When it does that, it's going to give it an argument. It's going to give it the response that comes back from the API. We no longer need this. We just have to let that thing finish up what it's doing. It finishes it, it calls my func, it says, hey, I've got some crap for you, puts it into here, cool. Now, inside our function block, we can work with that API response. We're going to do this in week 12. We're going to do this exact thing in week 12. But today, I'm going to show you, we're going to do it today, but not that one. We're going to do something a little different. So parameters are very important because they're placeholders, right? And arguments are obviously very important because they allow us to pass information to those parameters. And like I said, parameters are optional. Arguments are optional. And incidentally, you can pass a function that is looking for no parameters. You can pass it arguments and then access those arguments inside the function. Gets a little bit more convoluted on how you do that, but you can. So it works both ways. You can totally ignore your parameters or you can totally ignore your arguments. It works in both directions. Passing argument, like I said, you can pass any argument. You can pass strings, values, such as numbers, other objects, arrays, and functions. You can pass whatever you want into your function as an argument. So first, baby steps, right? Nice little baby steps. We're going to create a function that has two parameters. One is an array, and the second one will take a string. We're going to have the logic take that string and attach it to the end of the array. So what array method do we need to use? Yeah, we need to use push in order to do that. So let's go ahead and write that up. So create a function that has two parameters. I didn't say what the function is called. I'm going to call it add. And it takes two parameters. It takes an array and a string. So like I said, it doesn't care. There's no way to data type it. It's really just whatever you want to call those variables. You call them whatever you want. I'm going to call mine R and str because I like readability, right? It helps another programmer kind of know what I'm expecting. Okay? And then we can return. No, wait. Hold on. I'm trying to remember how that works. No, sorry, we have to store that. So we're going to do R is equal to R. Nope. we're going to do r.push string. There we go. And then we're going to return r. That's what we have to do. We can't, unfortunately, return r.push string because what push actually returns, bizarrely enough, is a Boolean thing saying, yes, this worked, is essentially what it pushes, as opposed to it returning the array, which would make more sense to me, but whatever. So we have to do the push and then return the array. Okay? Now we can call our function. So we just go equals, add, and I'm just going to give it an empty array, which is just a set of square brackets, and I'll just pass in Sean to it. And incidentally, unfortunately my script doesn't actually output it, so let's make sure we do a console.log my new r so we can see what it actually produced when we did it. And go ahead and click execute, and you should see an array with Sean in it. If you want to do it again, you could even, can I duplicate in this? Nope, that is not how you duplicate. Cool. Oh, and it puts me so far up on the screen. Here we go. I'm going to hit Command C, Command V, and get rid of this let. And why don't we write, all right, and right. Hit execute. Oh, it's just going to overwrite it. Oh, right. Sorry. Duh. This time we need to pass my new R in there. There we go. Now we got Sean and Amrit. And you can just keep doing it. Obviously, that's inefficient code. And that's why we have push. One more kind of interesting thing, just for those of you that like to go outside the box and do other things. These functions that we have available to us, these library functions like push and pop and some of the other ones that you haven't even used yet, like reduce or map or for each. These functions, you can actually overwrite them and create your own function. So, for example, pop, right, or push, the one we just used, there's an object inside JavaScript called array, right, which we've been using up to this point. Whenever you create a square set of brackets, you instantiate a version of that immediately, okay? Array has the push method, which you can access through its prototype. Don't worry if you don't know what prototype is. We'll talk about it at some point. Dot. And then there's the push. Push is a function definition. Because it's a function definition, it's just a value. If you wanted to, you could say, okay, cool, push is now equal to 5. And from now on, anytime you call array.push, it says 5. Because that's just what it's equal to. Or you can make it equal to an entirely new function definition and give a whole new function definition, making it more efficient or doing whatever you want to do to make it more powerful, which is really super cool because some of the functions that are built in won't necessarily do what you want them to do, and you may want them to do more, and you can actually create your own and overwrite theirs. All right? Cool. So if you click execute, it should say passed, and then that leads us to callbacks. 5 minutes maybe? 10 minutes? And we're good. Does anybody need a break? Are you good for 10 minutes? Okay. Don't fall asleep. All right. Last week we discussed how arrays have many methods available to them. However, most take a callback as an argument. And because of that, I didn't want to get into those methods because callbacks are a bit advanced. And I wanted to wait till we do the actual function one, right? Because JavaScript is asynchronous, as I pointed out earlier, callbacks are integral to being able to fire off logic at specific points, right? Callbacks are for now. When we're doing vanilla stuff and we're learning vanilla JavaScript, we use callbacks. We use callbacks right now because they're easy and they're kind of a little easier to understand. As we progress and when you guys take the advanced JavaScript frameworks class, you'll be using promises and you very likely will be using async and await. That makes callbacks a little less clunky and a little less garbage looking, but they are a little bit more complicated. So So generally callbacks are used in asynchronous code. However, there's many methods inside JavaScript that require callbacks in order to work with them. And a lot of those methods are with the array. For example, there's map. Map will actually iterate through the array. These are all iterators. Map will iterate through the array and modify each element, however you decide you want to modify it. So say you have a list of values and you want to multiply all of those by tax, right? 1.13. And you go through that list of array. You can do that, and you can do map. And what map will do is it'll multiply them all by 1.13 and then return them and rebuild the array with the new values, right? There's reduce, which allows you to basically take those elements and compare them against each other. And you can you can keep comparing them against each other, or you can mutate those two values. There's for each, which is essentially the same as the for of loop, except for now you're using a callback to do it. There's a whole bunch of them. The one that I was exampling here is map. As you can see, here's the array that we defined up here. We're calling the map function. And what we've passed it is what's known as a anonymous function, right? The same thing we wrote. There's no name on that. It's just an anonymous function. This is just a value. We've literally taken the definition syntax and plugged it in, all as one block, right? Basically what's going to happen here is map is going to start with the first number, right? It's going to pass it as an argument into the function, which we're going to store inside this L parameter. Now we can use the L parameter, add 1 to it, and we return it. When we return it, it gets written back in this spot. So 1 becomes, what does 1 become? Follow that logic. What does 1 become? 2, exactly. And 2 becomes 3, exactly. 4 becomes 5, 5 becomes 6, 6 becomes 7. So on and so forth as you keep going through. That's one way to do it. That is the most common way you'll see is people passing inside these functions like this. However, you're not limited to doing that because all map is asking for is a function definition. It doesn't care what function definition you give it, as long as you give it a function definition. You can also define your function as a named function outside, which has happened here. Function output L, same logic, exactly the same logic, only now I just pass in the symbol name directly to it. The operation is the same. Nothing has changed. All the execution is exactly the same, right? The only difference is now my function is sitting outside of it, instead of being an anonymous function plugged in. Yes, I know callbacks are confusing. And I know this is a bit overwhelming. The good news is we're going to write about 150 of these before the end of the semester. So you'll know callbacks backwards and forwards. Because every time we want to do events, so when somebody clicks the mouse, we need a callback. Anytime we want to iterate through an array with for each, we need a callback. When you guys write your thing for the guess a number, you're going to need a callback. You're going to need callbacks constantly, and you're going to write them so much, you're going to be like, callbacks, dead easy, so simple, right? And then you're going to try them in other languages, and you're going to find out, oh my god, these are available in other languages, and I can actually use these things in other languages. That's super cool. And yeah, callbacks are awesome. I like callbacks, if you can't tell. So let's write one now. Your first callback. We're going to write your first callback right now. We're going to use something called reduce, which will allow us to basically take two values and either mutate them or do whatever we want with them. We're going to mutate them. We're going to use reduce to do kind of a sum. We're going to basically sum all our numbers together. So the way we do that, I'll lock that off. We're going to say equals nums. And the method we're going to call is called reduce. And I'm going to write it like that. We're going to do this in nice little baby steps. Reduce is the method we're calling, and reduce is a method on arrays, right? It's available to us from arrays, and nums is an array. Okay? Inside here, we're going to give it a function definition. Ooh, right? We're going to pass it a function definition. An anonymous function definition, which has no name. So we're going to say function, like so. Set of parentheses for the parameter list for the function, and the set of curly braces. We're essentially just passing, I didn't even write it out, we're just passing that's all we're passing, just this guy here as a value, right? That syntax structure, right? We're just passing that as a value. What's going to happen right now is Mac will use this, and this will not blow up. This will not cause any issue. Mac will say, cool, I'm going to take num, and I'm going to put it in this spot. But I have no placeholder in there, so it makes it very difficult to get. And then I'm going to execute what's inside this block, which is nothing. We don't have anything inside the block. So, first, let's give map a placeholder to put the value in, right? And we can call it whatever we want. It doesn't matter. Somebody give me a variable name. Any symbol name you want. What's that? I still can't hear it from here. Say it one more time. Results. Sorry. I've been up since 6. Okay. So we're going to put function result. That's perfectly fine. So the first time this iterates, what is result going to be equal to? Nobody? The first time we iterate, what will result be equal to?
10.
Why 10? You're just coming up with a random number. Okay, let me quickly explain what it does again. Reduce iterates through this list. As it goes through, it takes those numbers and it passes it into the placeholder. So what will result be equal to? 256. That's exactly it. 256. So the first time we go through, it will be equal to 256. Now, interestingly enough with result, reduce, we actually have to define 2 placeholders. One for the current number and one for the previous number, so that it can create a comparison between the two. So we're going to need another symbol. So I've got result. Somebody give me the next one. Sorry, say it again. Final result? All right, final result. We better camel case it. It is JavaScript. So we'll do final result. I apologize for this. It's a little easier when it's all in one line. You can do yours as A, comma, B if you want to do that. A lot of people do that. I'm totally cool with result and final result. Now, this is just syntactic sugar, right? Meaning that it makes things more readable. It's a little cleaner looking. It's a little nicer to look at. I can actually hit enter here and pull this to the next line, allowing the block to be open for me to write expressions in, which is exactly what I'm going to do. I move it to the next line. I now have an open spot to write expressions. Right? Definitely easier to see. Reduce expects me to return. I have to return in order to populate the values back into the array. If I don't return, no values go back into the array and nothing happens. Okay? So I have to return. So let's do that. We're going to return. And I'm summing. So let's take a look at what's going to happen the first time. 256 is going to get passed to result. 0 will autofill final result. This will return 256. Next iteration. The value of 256 is going to go into final result, and 56 is going to go into result. Those two numbers will get added together, and it'll return back 312. Then it's going to take 312 and shove that into final result. It's going to take 72 and pass it in. That's going to become 384. The next time it iterates, it's going to do 94 and add it on, and I can't remember what that is. And then the next time it's going to do it, it's going to add 83, which I think comes out to like 561 or something like that, if I remember correctly. So the way we do that, to get it to keep adding those things together, is we do result plus final result. That allows us to take that number and add to the next number, and then take that number and add to the next number, and so on and so forth. And if we execute, should say passed, but obviously we want to see the value, right? So let's do a console.log, sum, execute. Sum is 561. And congratulations, you wrote your first callback. Now, we haven't talked about this at all, but we've been currently using very vanilla JavaScript. Probably about anywhere from ES 2015 and back is basically what we've been writing. It would be a total disservice if I didn't show you how you write functions in 2016 to 2019. The way we write functions in JavaScript now, and you will see this out there every so often, it's not as common, but it is there, is like so. Nums.reduce. We take this, result, final result, pass that into the function, return result plus final result. And we will get an error because there's no nums defined. But this is called arrow functions. Arrow functions take a parameter list, like so. They take the arrow, which says, hey, this thing is a function, like so. And they take a block. And that's ES6 to ES9. That's how we write arrow functions. So if you're eager to do that, feel free, because I will never mark that wrong. All right? It's definitely a good way to go. And actually, if you do it on an assignment, you get bonus marks for doing stuff like that. Anytime you think outside the box, I always get bonus marks. Otherwise, keep writing them the way we wrote them here. Any questions about callbacks? We're going to do it tons and tons of times, so don't be nervous about it. Yeah? Cool. So, how do you submit this? I will show you how you submit this. You scroll down a little bit, and you click this wonderful Get Code button. It's going to spit out a giant block. You're going to basically start your cursor at the top, move it to the bottom. You're going to hit Command-C. You're going to come over here. You're going to click on Labs. You're going to click on Lab 3. You're going to click Write Submission, and you're going to paste it. And then you're going to submit it. That's it. That's Lab 3. And then I'll mark it and give you feedback, hopefully on the weekend. As for the rest of the class, you're totally done. You're free to work on whatever you want. I would recommend working on the quiz, which you will find open under quizzes or under weekly learning. I think there's like 15 questions, and you are welcome to work with each other. Give me 1 second just to stop this video recording so it's not just 10 minutes of dead air at the end of it.